Okay, welcome to this next video. In this video, we'll be doing integration using partial fractions. Yes, you've heard it right, partial fractions. So in what situations can we do this? We can do this when we've got fraction of polynomials that we cannot use the law of logarithms, where if you let the denominator be u, there is no way of manipulating the numerator to become the derivative of that. So this does not work at all. So therefore, this gives us an opportunity where we can use partial fractions. So some examiners might be a little bit lenient and ask you in step 1 to decompose into partial fractions or resolve into partial fractions, but some others don't. But if you don't remember, a quick way is to make sure that if you let the denominator become u, you actually can't differentiate it to give you the numerator, and therefore you'll use partial fractions. So therefore, let us start by finding the partial fractions of this, and therefore we can then find the integral of that. So the way we will do our partial fractions, we'll take the expression and write it as 3x plus 3, and therefore we'll factorize this, and I think this factorizes into x plus 1 and x minus 2. Oh no, it's actually the other way around. So this factorizes into x minus 1, and this factorizes into x plus 2. So once you've done that, you can label your first term as a. So this becomes x minus 1 plus this becomes b over x plus 2. So based off of this, we can work out now by doing partial fractions, and this will just be a to the x minus 1 plus this will be, x plus 2, and this will be x minus 1. So once we've done this, we'll now use the method of elimination to try resolve this and get a solution to it. So we will let x equals to minus 2. So if we let x equals to minus 2, what we end up getting in the expression is 3 times minus 2 plus 3. And the other side, we can see that we will be eliminating the a by putting a negative 2 there. So we can just come and work out what b is minus 1. And then based off of that, this expression will give you minus 6 plus 3, and this will give us negative 3b. And therefore from here, we can work out that b actually is equals to positive 1. So this will be a good way of getting that done. And therefore we can come to our last expression now. We can let x equals to 1. By letting x equals to 1, we can eliminate b. So this becomes 3 times 1 plus 3, equaling, we now have x, we have 1 plus 2 in there. And this side will give you 6, and this side will give you 3. And therefore, this does allow us to then come to the conclusion that a is equals to 2. So what I'll do, I'll just continue working on the side here to save space. So what that means is that the expression that we have there, once we resolve it into partial fractions, looks like this, which is a. So there's going to be 2 over x minus 1 plus b, which is 1 over x plus 2. So this is their expression, and therefore now we need to integrate it. So what this means is that that integral that we're supposed to work out will now work out the part that we have resolved into partial fractions. Okay, so therefore I think you now are at a very good stage where you remember how to work this out. So remember that 2 is just the constant, so this becomes 1 over x minus 1 plus, we're still taking the same integral of this as well, which is x plus 2. Don't forget the dx there, don't forget the dx. And therefore, if you remember very well, if this is u, you'll see the part is the derivative of u. Again, if you label this v, this part will be the derivative of v, and therefore we can apply the rule for integration that we do for logarithms. So therefore, this becomes the absolute value of x minus 1 plus this becomes the ln of the absolute value of x plus 2 plus your constant of integration. So this is how you'll be able to do questions that involve integration using partial fractions. So first, you have to resolve it into partial fractions, and then secondly, you then have to take your integral. And the integral that you have to solve, then you have to use all of the techniques or any of the techniques that we have learned before. In this case, the techniques that are applicable is the ones where we integrate into natural logarithms, and therefore we can get those solutions. I hope this has made sense. I'm going to do one more video. I am looking at a real life exam type question, and we will see how that is solved. And hopefully after that, you will have much more understanding on how to solve questions of this type. So see you in the next video.